Molecular compounds in a nutshell. So these are compounds with covalent bonds. And if you remember, covalent bonds are compounds involving two nonmetals. So if you're looking at the periodic table, two elements from the right side of the periodic table. So we're going to talk about how to name these particular types of compounds and talk about some additional features. So what happens when molecular compounds are dissolved in water? So they're very interesting in the fact that if you look at an ionic compound, it actually dissociates. So look at the ionic compound, you see how you have the oxygen end attracting the one ion and then the hydrogen end attracting the other and pulling it apart. So in this situation, you have the H's attracting the negative end, and then you have the O attracting the positive end. Remember, it's because water has what's called a polarity, a positive and negative end that's able to pull the ions apart from one another. Compared to molecular compounds, you have no charges. So when water dissolves in a molecular compound like sugar, for example, the whole molecule stays intact. So you don't have dissociation. You don't have, C6H12O6, which is what sugar is. You don't see it breaking apart into carbons, hydrogen, oxygen. It doesn't do that. It stays an intact compound, but it breaks apart from other like compounds. So having a whole bunch of sugars together, you start breaking apart and dissolves. So that's a very unique feature of molecular compounds in that they don't dissociate. They don't produce ions. What they produce instead are whole molecules that are separate from each other and to your eye are invisible, right? Because ions are invisible when they break apart from their ionic compound. Same thing with molecular compounds. They go invisible because they're dissolved in the water. So how do they form? Nonmetal elements share electrons to form a covalent bond. Nomenclature molecular compounds are as follows. Prefix indicate the number of elements you see. So unlike crisscrossing for ionic compounds or you crisscross numbers and chart, you don't have to do any of that. All you have to do is specify what you see using prefixes. So you have to memorize these. So you have to know mono means 1, hexa means 6, di means 2, hepta means 7, tri means 3, octa means 8, tetra means 4, nona means 9, and penta means 5, deca means 10. These should be familiar to you from geometry class. The first four, a little bit more difficult, I guess. Mono kind of makes sense, 1. Di makes sense, 2. And tri makes sense. Tetra's a weird one. It's like, how the heck does tetra equal 4? But it does. So you have to memorize these. It's the only way you're going to be able to do this section. So here are the rules. Rule number 1, indicate the number of each element using prefixes and end name with IDE. 2, don't use mono for the first element. So CO is carbon monoxide, not mono carbon monoxide. So you never use mono at the beginning of the name, ever. You can use it for the second, but not the first. Also, notice the ending, IDE, not INE. Just like ionic compounds, you have to end the second element either in IDE in this situation for all these because there's no polyatomic ions. But remember, for ionic compounds, you could have IDE, ATE, or IT, depending if there's a polyatomic ion. Here, there's no polyatomic ions. So you're always going to end in IDE, always. All right, so here's an example, P4S3. All you have to do is write what you see. I see 4 phosphorus, so that's tetra. I see 3 sulfur, that's tri. Here's my name, tetra phosphorus trisulfide. Notice I didn't crisscross and look at the periodic table for the charges, none of that stuff. All you have to do is be able to relate whatever subscript it is with whatever the proper prefix is for that, and you're done. That's all you gotta do, really simple. All right, so let's look for these. SiCl4 and P2O5 will be the correct names for this. So this, remember, you don't use mono in the beginning, so this will be silicon. And how many chlorines do you see? 4. So tetra chloride. You're done. That's all it is. You notice how to use a periodic table or anything else? For this one, 2 phosphorus. So how do we say 2? Di. Phos. You see the first name is just the complete name of the element. There's no truncating it like you would for the second element. 5 oxygens. So pent oxide. That's it. That's all you gotta do. Real simple. Writing formulas for covalent compounds, ionic charges aren't used to write the formulas. So you're written based on the prefix. So carbon tetrachloride is telling you there's 1 carbon and 4 chlorines. You're done. That's how easy this is. It's a much easier system than ionic compounds. Bi3, you see 1 boron, 3 iodide. So this would be just boron triiodide. Remember, you don't use mono in the beginning. Two I's. And that's it. All right, what's the correct formula for this one? Phosphorus pentachloride. Phosphorus pentachloride. 5 chlorides. Done. That's how easy the system is. Sulfur hexafluoride, 1 sulfur, 6 fluorides. You're done. Dinitrogen trioxide. Dinitrogen tri means 3 oxygens. No crisscrossing, no charges. It's a really easy system. Identify each compound as ionic or covalent and give it its correct name. So now that you understand molecular compounds and you've seen ionic compounds before, let's just make sure you can connect everything. So for this one, SO3, 2 nonmetals, so that's going to be molecular. So we'll call covalent, covalent bond. MnCl2, there's a metal involved. So anytime there's a metal involved, it's automatically going to be ionic because it's metal plus nonmetal. This one's a little tougher. There's no metal, but these are 2 polyatomic ions. So 2 polyatomic ions is going to create an ionic compound because they're both ions. And the last one, copper involved. That's a metal, so that's going to be ionic again. All right, diatomic molecules, you need to memorize these just like you would the prefixes. So these are elements that do not exist by themselves. Easy to remember it is Hofbrinkel, which basically spells out the symbol for each element. So H is for hydrogen, O is for oxygen, F is for fluorine, Br is bromine, I is iodine, and nitrogen, Cl is chlorine. So if I say hydrogen, this is what I mean. When I say chlorine, this is what I mean. These elements are never, ever by themselves. So if you hear the element name by itself, you just put a 2 next to it. What if you hear sodium chloride? Do you still do this? Do you put a 2 next to? No. In a compound, all the rules apply. So you don't put the little 2 anytime. You just put NaCl. That's how you do it. So for these particular elements, either they're in a compound, using whatever the rules are for making a compound, or if they're by themselves, you put the little subscript 2 automatically because they do not exist by themselves. So that's molecular compounds in a nutshell.